jetzt in den Energiesektor. Wir alle wissen es, die Energiewende, die ist in vollem Gange und eine sehr große Herausforderung für Regierungen, für Unternehmen, aber der Wandel ist nicht mehr aufzuhalten und in vollem Gange. Die erneuerbaren Energien, vor allem, wo wir immer mehr hinwollen, die bergen aber auch enorme Risiken, beispielsweise für die Netzstabilität, weil eben nicht immer genug Sonne und Wind vorhanden ist, manchmal zu viel. Das heißt, in das Netz muss eben häufig eingegriffen werden. Das verursacht Kosten, aber unser Netz funktioniert eben nur, wenn immer gleich viel Strom vorhanden ist, wie eben auch verbraucht wird. Genau hier bietet eben das Thema künstliche Intelligenz enorme Chancen für Stromversorgungsunternehmen. Und wir hören jetzt gleich anhand eines speziellen Beispiels, nämlich der Elia Group, ein Energieversorger mit Hauptsitz in Belgien, wie man hier KI nutzt. Rachel Berryman wird nun darüber sprechen, wie KI eben die Stromversorgungssysteme sicherer und kosteneffizienter machen kann. Und sie wird auch erklären, warum der Bedarf gerade im Zusammenhang mit den erneuerbaren Energien an genauen Prognosen immer weiter zunimmt. Rachel Berryman ist Data Scientist und sie ist Deputy Head of the AI Center of Excellence bei der Elia Group. Herzlich willkommen, Rachel. Welcome, Rachel.
Thank you. So, thank you. I'm fully aware I'm the last thing standing between all of you and lunch, so I promise to try and at least make it worth your while. So the motivation for this talk was actually the EU AI Act, which most of you have probably heard of. The EU AI Act will classify pretty much all of our use cases at Elia Group as high risk. And I would like to talk to you all a bit about why that is not necessarily the case and why some of our use cases particularly actually help to minimize risk on our system. So first, what exactly do we do as a transmission system operator? What does that actually mean? What is the difference between 50 Hertz, 50 Hertz here in Berlin and Elia Group? I'll just explain that very quickly. So we run the high voltage electricity transmission network. So basically the only end customers that we have are huge electricity consuming industries. Otherwise, we basically pass electricity down to the lower voltage levels. In the Berlin region, some of you might have walked by the distribution operator this morning on your way here at Stromnetz Berlin. They manage more of the lower voltage network. So we manage the high voltage network. We are responsible then for keeping the lights on partially in this room today and for 18 million people in the former east of Germany and Hamburg, and all of Belgium, which is around 11 million people. What exactly we do in our regions? We own and operate the high voltage grid. So all of the maintenance, all of the actual assets, that's under our control. And we are responsible that at every second supply exactly matches demand so that we keep 50 Hertz as the operating frequency. If this doesn't happen, that's on us, and that means that we have giant blackouts, which we don't have very often on our grid, but it's important that we keep that. We also help facilitate the market so that the various players in the system in our control region can have a free market in which to play. This is how the control region looks in Germany. So as you see, we're pretty much right in the center of our control region today. But want to bring your attention to some of the figures on the right, because this is what motivates a bit this talk. So between 2010 and last year, you see that the share of renewable power in our control region here in Germany on the 50 Hertz control region went from 25% to 65%. So this is a massive, massive increase. You can also see the installed capacity in the grid area. This is also interesting. We don't build the capacity. We don't actually build new solar panels, new wind turbines. We just make all of the connection and kind of try to make more need in various ways for that. Power consumption has stayed roughly the same, more or less, 98 around-ish terawatt hours, but just where that power is actually coming from has drastically changed. One quick last point here. By 2032, we want to get this number from 65 up to 100. But then what this means for our grid is a lot of change. So in the past, our job was actually, so keeping this balance between demand and supply was actually much easier because we basically only had to control one side of the equation, which was the supply side. So basically, we looked at what the consumption would be, when are people coming home, cooking dinner, when are the various industries turning on all of their large machines, and basically told the generation side to turn up or down to follow that. In the future, this will completely change to what we call a prosumer-centric system. A prosumer is someone who both produces and consumes. So you could think of people who have solar panels on their house. You can think of people who have electric vehicles that they could maybe use flexibly, because if you don't use electricity, you're also kind of producing, because you're impacting that balance from the positive sense. And these actors on the consumer side, who before used to kind of make the decisions and say, hey, this is how much we need tomorrow, they will actually have to change, and they will have to follow the generation, which is much more variable. We can't obviously tell the wind to blow and the sun to shine. If we could, the weather would look much different here in Berlin than it typically does. So what these massive changes mean is that we will have to be much more scalable than we were in the past. So this is already the case that we have kind of massive moments of, for example, a whole bunch of wind on the grid, where then our system will have to scale up and down very rapidly, rather than as it is now, which is much more kind of in the middle. We'll have a lot more intermittency and uncertainty. Renewables are much more intermittent than a lot of the generation that we have today. And of course, we have a lot more complexity on our grid. This at the same time that people want affordable energy still. We obviously still want to keep it secure. This is something that we really can't overestimate how important it actually is, though, that we still have electricity every day. This cannot be something that we let fall by the wayside. And obviously that it's sustainable. So people want to have renewable electricity, but they still want to have electricity whenever they want it. They want to be able to charge their phone whenever they want it. They want to be able to drive their electric car whenever they want to. All of these things are what we have to manage going forward. One help, though, that we have for this is basically data. So all the new data coming not just from our generation units, but from electrical devices everywhere. This is great, but then we actually need to use all of this data, which for our company is a pretty new task, and also for consumers, for end consumers, that you actually start to change your behavior, look at your data, look at what you're actually doing. This is not something that most people are used to doing, as well as companies are used to doing. So that's a bit the background, why my team was founded then officially almost 4 years ago now. The AI Center of Excellence, so this was our mission, to really focus kind of in our company on enabling everyone in the group to use the new data that is coming through AI, ML, and advanced analytics. The very important kind of asterisk that I would add here is where appropriate. So it was never the goal to just kind of like sprinkle AI on everything and say, oh yeah, we did a great job. No, we want people to really understand it. One thing, though, that was quite helpful for that in our company is we're a company full of electrical engineers, actually. So these are people who are quite technical. They like new technology. They like technology in general. They want to understand. So our team, as kind of an internal consulting company for all things AI, data science within the company, went out and basically said, OK, who are our clients within the company? Who do we want to make ourselves available to? And what do we want to offer them? And we had kind of two main clients, still do. Business product owners, so these are basically people who need some type of ML or AI solution. They either have some type of product need, where then a machine learning component could be useful, or it's really that they're in charge of a full ML kind of product. But they are not machine learning experts on their own. They don't code, they don't want to, that's fine, that's what our team is there for. We also, though, because we are such a technical company, have a lot of people that we call citizen data scientists within the company. So these are people who actually have coding experience, are interested in machine learning, and want to do it by themselves in their area, and are also often really experts in their domain's data. And so we also said, OK, we, as the AI Center of Excellence, as this kind of alone acting consulting part, we will only get so far. We would like to actually enable these other people in other areas of the business to also work with machine learning when they have those skills. So for both of these kind of profiles, we provide trainings and services. So on the training side, we basically helped the citizen data scientists to kind of upskill. Together with a university in Belgium, we made an Intro to Data Science for Energy course for some of the people who wanted to do that. Taught them more Python, even though especially now, a lot of the new people coming out of engineering programs have already worked in Python quite a lot. So this is quite cool. On the business side, we did a kind of tour of AI demystification, we called this. So this was basically going and explaining what is machine learning. This is not magic. We explained how linear regression works, which they mostly remembered from their statistics courses in university. And then followed that up with a use case identification workshop where we would really look in their area, what are problems that you have, where can machine learning be helpful? Again, not trying to throw AI at everything, but really find very concrete use cases. And this almost worked too well, because within 3 years, we drastically grew the number of use cases and had to grow the team from, at first, 2 internal data scientists to it is now at 25, all working full-time on use cases. But that's great, because we didn't just hire these people and then say, go out now and do some stuff. Rather, the use cases came, and then we had to hire people to actually do them. By far, the most of what we do in the AI Center of Excellence is this bottom right component, so full ML model lifecycle management. That means finding the use cases, training the first models, putting them into production, and then actually managing them. So the entire ML ops cycle, that's 90%, I would say, of what we do. The rest is really just to support the funnel, basically, for models coming into that lifecycle management system. Okay, so now I'd like to talk to you about one of our use cases that's really, really, really at the core of what we do, which is forecasting the system imbalance. So this is really, truly the crux of what we do day to day. System imbalance is exactly as it sounds. Instead of the system being balanced, balanced means supply perfectly matches demand, which is what we have to have every second. Imbalance basically means in the time up to the present moment, one of those sides is higher than the other. And as part of our mandate as a transmission system operator, we have to keep supply and demand equal. So as it gets closer to the present moment, basically we have a bunch of different measures that we can put into place to force supply and demand to be equal. The closer you get to the present moment, the more expensive these measures become, because a lot of the energy generators are very, very expensive to turn on and off. There's ramp-up time and cost. Also, there are some disincentives for us to really do a lot of these things at the last minute. It's better if more of this balancing happens in the market. So what we try to do is do more and more of this earlier. That means, though, that we have to have better forecasts, which is very important. What happens when we have to use more of these measures later on? Most of the time, what it really means is that either we have to curtail renewables if the supply side is too high. That literally means cutting off the input of wind, of solar, etc., which obviously not really what we want to have. Or that we have to turn on mostly diesel generators at the very last second to make up for lack of supply. Both of these things are not things we want to do, but to keep the lights on are things that we sometimes have to do. We want to avoid that, also because who pays for that in the end? All of us sitting in this room. This is why we want to have better forecasts. So the system imbalance forecast that we used to have before my team in the AI Center of Excellence took this over and made it internally, came from an external provider. So system imbalance is basically, the difference between supply and demand. It can be either positive if there's too much generation or negative if there's too much demand. One other way to think of this, though, is that it's kind of the residual error of all the other forecasts that we have. Because if all of our other forecasts, so if the forecast of how much load, how much consumption is needed on the grid, all of the generators, if all of those were perfect, we would have no system imbalance. So from a data science perspective, you can kind of think of it like that. We had the goal to get our system imbalance forecast to less than 100 megawatts per minute. However, many of these input forecasts that go into it are worse than that. So is this also even possible, was the first question that we had. Then we had some other constraints around this forecast, because we wanted to publish it on our open data portal, which we did. I'll give you guys a link to that in a minute. But we had a question, which was, when we start publishing this system imbalance forecast, will market participants actually act on it? And then will that, in turn, make our forecast worse in the future? So for example, if we say to generators, hey, we think in an hour that we're going to have way too little generation, are they then going to start bringing in more? And then that actually means that our forecast is wrong, and now we might actually have an imbalance in the other direction. This was a concern, has actually happened a bit, and so we've had to manage that in successive versions of our forecast. The other problem, again for the data scientists in the room, is that we make this prediction every minute. However, some of the input features are only updated, let's say, every 15 minutes, every hour. This is another thing that we had to manage. Finally, when we set about trying to train this model internally, we talked to the data team. They said, yeah, we have a lot of historic data. Here you go. However, a lot of the historic market data is updated after the fact, because in the electricity system, there's a lot of balancing of the market that happens sometimes days, weeks later. And so all of the historic data was correct in that it had all of these corrections on it later, but that's actually not useful for the problem in real time, because there we don't have the corrected data. So we actually needed to save. We needed to make a new database of historic data of the actual what's available at the time. So this was another constraint and challenge. However, we still made a model for this. We've now had, I don't know how many versions in production, but it's been production for over a year, our internal one. QR code is right there that takes you to the Elia Open Data Portal where this is published. The old version that we had that we bought from an external provider, which, by the way, going back to risks, is also a risk whenever you're relying for such vital forecasts on external providers. The root mean squared error in the first deployed version. That was just to check that you're all still awake before lunch. Okay, so yeah, improved by 30%, which is quite good in the first one. We are still not exactly at the 100 megawatt goal, but we're very, very close. And again, given that a lot of the input forecasts are still worse than 100 megawatts, that's still quite good. Yeah, so you'll see also if you follow the QR code to the Open Data Portal, you can also click on Analysis, which shows then a graph minute to minute how the forecast is compared to the actual. So this was just one example of one use case that really shows for this new energy system, where again we have so much new data coming in from all these different devices, all these different new generators, have to then provide more information from our side to the other actors as well. System imbalance forecast is a perfect example of that. What we are doing. And I think this is also quite a good example of, again, showing how we're actually lowering the risk, improving the risk using AI. So AI is not only increasing risk, it's not necessarily such a risk to give certain decisions to AI, but rather that this is really essential for our system operators to be able to do their job and for us to be able to lead and continue to manage the electricity system going forward. So now I'd love to take questions.
Here's the first question. What are some of the metrics you use for forecasting system imbalances? Time, week of the day.
Temperature, football matches. I get this one.
Yeah.
Yes. And which ones have the biggest impact? Any surprises? The football matches one is great. I actually had an example of this that I left out here, but there's this really classic example from National Grid, who is our kind of equivalent organization in the UK, where they had a load curve, we call it. So this is basically the graph of over the course of the day, how much consumption is there. And mostly this looks the same pretty much every weekday. It goes up and then goes up in the evening and then goes back down when people go to sleep. And there was one evening on like a Tuesday where this was completely jagged and strange looking, which completely throws off all of the system imbalance forecast. And actually what happened was that Germany was playing England in football, and you had these little jagged peaks at halftime when everyone was like turning on their tea kettles, and then at the end when people were finally finished watching the game. So yeah, this is actually something that we are starting to incorporate in this forecast, which is kind of this like world knowledge. But this is actually so hard because, okay, something like a football match, yeah, you could always scrape Twitter and see, okay, who's playing, who cares, is Hertha playing today, for example, for the Berlin region. But there are so many things that are new coming up that it's so difficult to say, is this something that's actually going to have an impact on the demand, and in which direction? Take, for example, the COVID pandemic or the first lockdowns. Which way actually would that impact our consumption? Because, for example, if everyone's staying home instead of being at the office, does that actually change so much day to day? Okay, rather than being in the office, maybe it's at your home, of course, where the electricity is being consumed, but is it really like a market difference in quantity? All of these things, so this kind of last step of like not just what is happening, but what impact does it actually have on the grid, on consumption, or on generation? That's the really difficult part. But yeah, this is something that we are including in new ones. Then the other ones that they asked, time is a huge one, week of day, also important, yes, but related to time. Temperature, this is a very interesting one, especially in Europe. It did not used to be the case that in the summer we actually had increases in electricity use with higher temperatures. Now that people are starting to drastically increase their use of air conditioning, this will change a lot.
Mm-hmm. Okay, next question.
Mm-hmm. What do companies need to implement an AI center of excellence? Data maturity checks, maybe. How can you get started? This is a funny one, because I would say we still have a long way to go, actually, for data maturity within our organization. But I think if you keep waiting to start an AI center of excellence until everything else is perfect and mature, first of all, nothing is going to be perfect and mature because a lot of data maturity has come from us going to the data team and yelling and saying, we need that data, make it available. So sometimes when you have use cases, it can actually help drive the maturity from a demand perspective.
I have one more question from the audience. Love how you described how you're working on establishing a hybrid data culture. How does your team ensure that all use cases are aligned? How do you create transparency of the use case landscape?
Okay, there's a lot of questions here. I'm not sure exactly what a hybrid data culture means, but the use cases are aligned is not really something that we care so much about, because we more do use cases because the business needs it. Punkt. So if people need it, then we do it, and then it's not a question for us in the team, is this use case like similar to other stuff we do? We do things that the business needs. However, because we have two similar organizations in Germany and Belgium, of course we always check on the other side, do you guys also need this forecast? That's a very interesting one, because you would think that, for example, if we do something on the German side, it would be completely replicable on the Belgian side. That's most of the time not the case. The systems are different enough that actually even for the same forecast, like system imbalance, the features on one side or the other, the input data that's relevant, are often very different. And how do we create transparency on the use case landscape? We communicate a lot about the use cases we do. Again, always going back and forth between Germany and Belgium as well, to make sure that that's very openly communicated.
Rachel, thank you very much.
one more.
Yeah, because you mentioned it earlier, the EU AI Act. So how does the new EU legislation impact projects like the ones you presented?
Yeah, so far, well, first of all, so far the EU AI Act has not been ratified.
But it will be probably in the next.
Exactly. The other thing is that so far it is not, and we're in obviously quite a lot of discussion groups with other critical infrastructure organizations. So critical infrastructure, you can even think like Deutsche Bahn. I spoke yesterday at the speakers dinner to Rafaela from Aldi Süd, and she was saying they're also critical infrastructure, which I thought, wow, true. And I hadn't thought about that, so need to talk with them more as well. But basically how it will likely work is actually just that we will have more reporting requirements for use cases that are very critical, which is not necessarily a bad thing, I don't think, but of course it will take more time and resources. But at the moment, that's all that has been kind of agreed upon so far. How exactly we will have to report, not talked about in the AI Act as it is yet. So it will really take a bit of trial and error once it comes into play to see.
And can the energy sector function without AI at all anymore?
I definitely don't think so, because especially, again, what I showed today is AI. It's also forecasting methods that have been around since the 70s and 80s. So if we stop using AI, aka completely normal forecasting methods that have been there for a long time, no, it will not be able to function, and in my opinion, not something we should do.
Thank you very much, Rachel.
Thank you.